Good. Because if it was negative 5, what would be true? Well, you'd be dividing by 0, so the function wouldn't even be defined at negative 5. Okay? We're going to talk a little bit about that today, how that affects things. But here, they want me to find, it says f prime of a. Okay? So there's kind of two ways to do it. And the book hinted at this. If you use definition 1, you can kind of get f prime of a directly. The limit as x approaches a of f of x minus f of a over x minus a. Okay? This is, if you think about it, this fraction is the slope formula, right? Slope of a secant line. And we're taking the limit as x gets close to a, and we remember that as the secant lines, as x and a get closer and closer together, you're approaching the slope of the tangent line, which is what we call f prime of a. But what I had you guys do in class is not that. I had you guys doing this in class, this definition. I'll write it here, definition 2, okay, which is that f prime of x is the limit as h approaches 0 of, what's the difference quotient that we put here? Yep, minus f of x, and then all over h. This is the more commonly used definition. And so what most people probably did was, you find the derivative using this. What's that?
And that created a mess.
Oh yeah, it's going to be a mess. Okay, and then you go ahead and do enough algebra that you work out what the derivative is, and then the last thing is you have to plug in where it used to say x. We're going to have to put a 5 because it says a is 5, and we want f prime of a. Okay, but let me go through the mess with you a little bit because I think that's why you guys asked. So we have. Okay, well, f prime of x, if I just go directly to this definition 2, they call it, I have f of x plus h. That means where it used to say x, we want to throw in x plus h, right? Where it used to say x, I'll throw in x plus h, minus f of x, all over h. And Mike, when you said a mess, you're right, because you have little fractions on top of this big fraction. And so what I wanted to show you is how to deal with it. So my hint was, look at example number, was it example 5, I think? Okay, so example 5, let me show you what they do. Okay? First thing is, they don't like fractions on top of fractions. Now if you think about this, we are dividing by what? H. So dividing by h is exactly the same as multiplying by what? 1 over h. And so they're going to write the 1 over h in front. And then they put these brackets, and then they just say 1 over x plus h plus 5 minus 1 over x plus 5. And by the way, I see a typo. I'm taking my red pen out. Wow, we're at 8:07. Paul already made an error. And that is, when it says derivative, I need to remember to put limit as what happens. Now that's going to be the last thing I do, is take the limit as h approaches 0. But I want to put that in where it belongs. All right, back to our program here. So can you subtract these fractions? Well, you can if you get what? Common denominator, right? And if I said, how do you do 1/3 minus 1/7? What's your common denominator? Yeah, but how do you get 21? What do? You multiply the denominators. And so that's exactly what I'm going to do here. I'm going to retain the limit as h goes to 0 here, and I'm going to keep the 1 over h here. But when it comes to these fractions and I want to get a common denominator so I'll be able to subtract them, the common denominator is going to be the product, s plus h plus 5 times x plus 5. X plus h plus 5 times x plus 5, which means I need to multiply the top and bottom of the first fraction by what in order to get it to have that denominator? The other denominator. And so the new numerator is going to be what? X plus 5. That's right. X plus 5. Does that make sense to people?
Yeah.
Let me show you on the other one in slow motion. What is it that I'm really doing to this second fraction? I'm multiplying top and bottom by what? X plus h plus 5 over x plus h plus 5. So you're not changing it. You're just multiplying by 1, but you are changing what it looks like. And so you get up here x plus h plus 5 as this numerator. Okay, so we have now limit as h approaches 0, 1 over h times, and now you could subtract the fractions and you'll get x plus h plus 5 times x plus 5 in the denominator. And in the numerator, you just have to do x plus 5. Now here's a mistake people sometimes make. Remember, you're subtracting that whole numerator, right? And so what happens? You have to distribute.
It's basically, you're adding that much times -1.
Yeah, times -1, you're distributing that negative. So if you think about what we have now, we have the limit as h approaches 0 of 1 over h times, and what do you end up getting in that numerator at this point? Almost. Negative h, right? Who's with me up to this point? Good.
That wasn't what I was going to do.
So now, if you think about it, you can cancel, right? See, right now, if I plug in 0, I get 0 over 0. But I can cancel the h's. Why? Because everything is multiplied, right? And then I just have negative h times 1, and I have h times this times that. So these h's can cancel. So now I have the limit as h approaches 0 of -1 over x plus h plus 5 times x plus 5. Now can I plug in 0? Oh, wait a minute. It just died on me. Is it back? I can see it, but you can't. That's stupid. Really? And I just killed it. Okay. So it's about to die on you, so I'm going to kill the recording, but the answer, maybe I can get it in quick. Nope. That's ridiculous. Just to try and finish this up, when you plug in that 0, you'll get -1, and you'll get x plus 5 squared, and now you're set. You can go ahead and do that. Now there was a part B, right? Part A, you have to find f prime of 5, and so instead of having -1 over x plus 5 squared, we said we're going to put 5 in for x. And you get -1 over 100. That's the answer to part A. What did part B ask? Oh, an equation of a line, right? Do you guys remember the form we've been using for the equation of the tangent lines? Point slope, yeah. So just a reminder what that is. Point slope form is really handy. You do y minus y1 is m times x minus x1. We got this now, right? This -1/100th is what? That's my slope, right? So I can throw that in here, -1/100th for the m. And do they give you in part B, do they give you a point? I think they do. What was the point in part B? Oh, I guess it doesn't say. Yeah, for 35. Because if you think about 35, all it told me was that A is 5. Is that an x value or a y value that they gave me? That's an x value. So where does that 5 go? Right here, where it says x1. What I don't have yet is I don't have the y value. But if you think about it, you can get it, right? So in order to fill this piece in here, what do I need? I need f of what? 5. And f was 1 over x plus 5, so it's going to be 1 over 5 plus 5, which is 1/10. So there's your equation. Y minus 1/10 is negative 1 over 100 times x minus 5. So number 4 from the group work. We had f of x was, oh yeah, x to the n power. And I said n here is what? Did I say any integer or did I just say positive integer? What did I say? I said n integer. That's funny. I'm going to say a positive integer, and then I'm going to think about, could it be other things? Okay. So we're going to, actually, we did an example of this in class, right? We did the example when n was what? Didn't we do n equals 4, x to the 4th power? Do you remember what the derivative was? The very first problem we did. It was 4x to the 3rd. That's right. It was 4x to the 3rd. So then the last problem on the group work, and I don't know if you guys did, I don't know how much time you guys had for this, because I think we worked about 25 minutes on the whole thing. So, well, let's look at it now. So we're going to do f prime of x, the derivative. And so I do the limit as h approaches 0 of f of x plus h minus f of x all over h. And so that's the limit as h approaches 0 of what? What goes here? What's f of x plus h going to be? Well, it'll be x plus h to what power? To the nth power, whatever n is, minus x to the n all over h. And if you remember, the real challenge for the number 4, it was, hey, how do you do x plus h to the 4th? Do you guys remember the shortcut we went over? That's kind of a nice little trick. Yep. What is it? Duncan's showing me this picture of a triangle, right? What is that? Pascal's triangle, right? So if you remember right, what we did was, let me do this. Let me write everything down. First of all, you remember we needed a much bigger fraction, right? And I'll just put the minus x to the n over here, okay? And then, yeah, what Duncan mentioned was, yeah, you had Pascal's triangle, right? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, etc. And you go as far as you need. Now, how far do we have to go? Well, I guess that's the issue, is we're on row n, whatever that is, right? So, I don't know. But we do know the pattern, and that's kind of the idea here. Let me ask you guys this. Can you tell me what the first term of x plus h to the n is going to be? It's going to be x to the n, right? Because in Pascal's triangle, there's a bunch of 1s that go down this. I mean, you go farther. It doesn't matter how far you go. The first term is always a 1. You guys with me? So the first one here we're going to write as x to the n. Now the next term is going to be plus something x to what power? N minus 1, right? If we were doing x to the 4th, the next one is something x cubed h. Remember that the powers of x go down and the powers of h go up. You're killing me, computer. So I don't know what that something is yet. And then I'm going to put another plus. I'm going to put a blank. Can you tell me what the next term is going to be? Plus what? X to the n minus 2 times h squared plus dot, 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 all the way up to h to the n. Okay, so that's what it equals. I guess I have one more question for you. Do you guys know what goes in this blank right here? You can see it from Pascal's triangle. 2 or 3 or 4, right? It's the second. So what would it be? In the general case, when we go to row n, this is going to be n. Does that make sense? See, when I do x to the 4th power, the second term is 4. Does that make sense? If I do x squared, I know the middle term is a 2. What I'm saying is whatever number you're on, if I'm doing 5th power, it's 5. Whatever it is, that's an n. And that's important. That's important here. Okay? So here I go. Remember what you do next is you simplify this big mess. Do you see anything that'll simplify? X to the n, right? You have an x to the n here, and you have an x to the n there. So that goes away. What's true about every other term in the numerator besides the ones that just went away? They all have an h in them, right? And so what you do, you may recall, is we're going to factor out the h so we can cancel it. So we have the limit as h goes to 0 of h times, so that green stuff went away, but everything else had an h in it, which is great, because what's going to happen is we'll factor out the h and then we'll cancel it. Now here's my question. What is left in the parentheses right there? Well, what's the first term going to be? N x to the what? N minus 1, good, plus, who cares? And the reason I say who cares is this. What are we about to do next? We're going to take the limit as h goes to 0. Of what? Of the stuff in parentheses. What's the stuff in parentheses? It's n times x minus 1 plus stuff with h's. And so what's going to happen to all this stuff with h's? It's going to approach 0. And so we just computed, therefore, that the derivative must be n times what? Yeah. And that's my bing bing rule. I can now do all kinds of derivatives using bing bing. Watch. The fast way to do the derivative of x to the 4th. Remember how long this took us Friday? I'm going to use this little rule here. Bing bing. What I mean by that is, if you want f prime of x, bing, take that exponent and put it out front. Bing, write x to what power? N minus 1 would be 3. Done. Well, isn't that nice? Does it always work? Here, let's try this. F of x is x to the 7th. F prime of x would be bing, bing, done. Ha-ha. Well, that's kind of nice. So, in theory, this is going to speed up our calculations significantly. And I said, well, I have to cover this section before we take an exam. All right? So do I still need to know how to do the whole thing with the difference quotient, all that algebra? Yes, you do. Okay? There will be times that you come across a new function that doesn't get handled by bing, bing. Actually, the complete rule is bing, bing, bong. We'll talk about that next week. Okay. But for now, bing, bing is what we're seeing here. Okay? The power rule, they might call it, I think, in the book. Okay? So today is really about giving you guys shortcuts to finding derivatives. Did you guys take a look at section 2? How'd the quick checks go? Should I go through any? 5? Okay.